Singh, NIT Patna, and Dr. Rajiv Misra, IIT Patna, to chair the session. I would like to invite them on the dais. There is an housekeeping instructions. Anybody who want to have questions with any of the authors can have their questions after all the presentations. I would like to call Kunal Abhishek to paper ID 28 to have his presentation on standards for electric curve cryptography in a public key infrastructure design.
Good afternoon, everybody. This hall is booked for only 5 p.m. So organizer has given me only 1 hour to complete this academic session. So we have to be professional enough. This is also a requirement for any speaker. Whatever the time is being allotted, we have to stick by the time. So we have only 10 minutes time for every speaker. So within that 10 minutes time, you just show the salient point of your paper and 2 minutes for the 2 minutes for the discussion. Right? Only one question. During the tea, you have a discussion with the other participants.
Good afternoon to all. This is Kunal Abhishek from SET Chennai, working as Senior Research Associate. I have been working with defense for more than 6 years, and there I have encountered one problem, practical problem in implementation of PKI with ECC. That is okay. So before going ahead, I would like to start with some introduction kind of thing with ECC and RSA. So ECC is a state-of-art asymmetric technique that is termed to be a viable replacement of traditional RSA. The main reason is that ECC is faster, cheaper, and more secure with a given key size than RSA. You must be aware of these two technologies. ECC is a modern technology, and it is based upon the a mathematical problem called elliptic curve discrete logarithmic problem, which has got fully exponential time solution if you want to crack the system. Whereas the RSA based systems are based on integer factorization problem, which is supposed to be a less tougher mathematical problem to solve. But the thing is, when we design and want to deploy a public key infrastructure based on ECC, there are so many problems we will face. This paper is all about that. So public infrastructure based on RSA is successfully deployed and practiced across the globe. Thousands of CAs are practicing these things, certification authorities, but we have only 4 or 5 certification authorities which is practicing in the ECC domain. And in fact, unfortunately in India there is no such certification authority licensed by certification, that is the controller of certification authority. So actually RSA key has got high size, key sizes that leads to slower performance in different PKI activities. We will discuss which PKI activities are those. And very few companies, like I told, very few companies like GeoTrust, VeriSign, Cortex, etc. practices ECC based PKI due to its extremely complex design and non-interoperability problems. So what we look at is the major issues with ECC based PKI design. The first issue is the non-interoperability among the systems and within the system components. Second thing is the security considerations we will take into account. And the third one is the patents problem. One of the main reasons for the above issues is that no fixed standards has been given or finalized as of now for ECC based PKI. The above issues can be resolved up to a great extent by adopting appropriate standards. So, as far as our contribution is concerned, we address different non-interoperability, security and patent issues caused due to inappropriate selection of the standards in this paper, and we have listed out most suitable standards and protocols for designing ECC-based PKI to avoid these issues, keeping cryptographic security and patent issues in mind. This paper also includes such standards which are available in market. Based on those standards, we have got dongle and other things to be used in the PTI system. So we have listed out the very few set of standards. We will see. So the first problem is the non-interoperability problem due to standards. So this is because of the lack of common standards for facilitating interoperability among the systems and within the system modules, and it is considered as the main hurdle for ECC-based PKI deployment. One way to achieve interoperability among different entities or modules in the system is to specify the cryptographic schemes well before starting any communication. We can see the SSL, example of SSL, that is secure socket layer. This thing we are doing, we are just specifying the cryptographic schemes just before starting any communication with the two parties, between the two parties. So, and in addition to that, other way to achieve interoperability among different entities or modules in the system is to follow the same set of established standards and schemes so that there should not be any compatibility issues. And careful selection of stable standards would encourage interoperability. If we see, there is a very good standard called PKCS, Public Key Cryptography Standards number 13. These standards are given by RSA Laboratory, and it is not finalized as of now, as 2010, if I am not wrong. And all the things we need while designing an ECC-based crypto system is to follow this standard. But since it is not finalized, we will encounter some problem in that. So, another IEEE standard, that is P1363 standard, is defined for public key cryptography, but it does not mandate minimum security requirements. And as I told you that our main concern is security consideration also. Security means cryptographic security. So it doesn't mandate any minimum security requirements, which is our one of the major concern. This standard also gives plenty of options that definitely will cause to lead to the interoperability problem. Patents are also there, since it's, most of the patents are filed by Certicom company, which has been taken recently by BlackBerry or some one company. And this holds around 130 patents in ECC. So if you want to design an ECC-based PKI, it leads to a high cost and other things. So we will take a middle way to just use this technology in our PKI design, while we should not touch any legal problem and other things. So like one of the example is given that like point compression on an electric curve is under US patent some number, therefore we don't recommend point compression in our PKI. Essentially we need well established royalty-free standards and the protocols that can ensure security at one hand and legal clarity at the other side. So what are the cryptographic securities issues?
Now conclude it within 2 minutes.
Okay. So the cryptographic security must be ensured in the PKI. That's why we have recommended that we should follow FIPS guidelines for that. And these are, you can see in the chart table, so many standards are given: ANSI, IEEE, ISO, NIST, SECG, NESI, IPA, RSA Lab. And for a fully interoperable PKI systems, we need to limit down the options of the standards and protocols listed as above. So we have given some recommendations like what curve we should use, what key sizes should be taken, and how we can keep our private key as a stored location and all. So there are so many standards I have listed out. You can go through it. And then a hash function for digital signing and all, and no point compression to be used. These are some things that we have incorporated. And after that we will incorporate one of the requirements, that is browsers, because we distribute the keys and all things to the users. So some browsers are available there, like Mozilla Firefox, and as well and other web browsers. And the conclusion is that we address interoperability, patterns and security issues due to diverse standards in ECC, and we have listed out various standards for particular include. And okay. And my sincere thanks to Commander F. Rajada from Indian Navy.
Sorry, we are not giving you sufficient time. So, if you have any questions, please discuss with me during the tea time.
Okay, thank you.
Next speaker.